Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be upon everyone. Welcome back to my channel. So today we're going to be doing the first question in the series of hard SAT math questions when you're dealing with the quadratic algebra section of the SATs. So you have the question 3x squared minus 9x plus 4 equals 0. What are the values of x that satisfy the equation given? So we're given the options -9 plus or minus 3 root 11. That's for option A. Then B, we have 3 plus or minus the square root of 33 divided by 2. C, we're given another option, and D, we're given another option. So the goal is to teach you how to think about a problem like this when you see it on the test. The first thing you have to realize is this. Many students make the mistake of using the factorization method or completing the square method and even sometimes the graphing method. This is absolutely not necessary. When you see a question like this on the SATs, you look at the option. The option is where you get the tip from, right? You can see all four of the options have the plus or minus as well as the square root or a radical. That just means you have to use the quadratic formula to solve a question like this in order for you to get the answer. Because one, you have a complicated equation, 3x squared minus 9x plus 4, and then you have complicated options that have plus or minus as well as radicals. So all those three information combined is just telling you not to factor, not to use any other forms of or method of solving quadratic equation, but to stick to the quadratic formula. So solving this, we have the solution. We first of all write out the quadratic formula, so that will be x equals negative b plus or minus b squared minus 4ac over 2a. And now we know that since this is a quadratic formula, we have to determine the value of a, we have to determine the value of b, we also have to determine the value of c, and we have to go on to substitute those values into the equation. So we have the value of our a to be 3, so a as in ax squared plus bx plus c equals 0, so that we have the value of a to be positive 3, the value of b to be negative 9, so the value of b to be negative 9, and c, the value of c to be positive 4. So now that we have all of this information, all we have to do is just simply substitute. So you have x equals, well, we have our b to be negative 9, so that's going to be negative 9 plus or minus the square root b squared, so that would be negative 9 squared minus 4 times a, which is positive 3, times c, which is positive 4, right? And then all of that information divided by 2a, that's 2 times a, which is 3, so 2 times 3, so you have x equals negative 9 is just 9, and then you have plus or minus the square root. Negative 9 squared is simply 81, minus 4 times 3 is 12, 12 times 4 is 48, so minus 48 divided by 2 times 3, which is 6. So that will be x equals 9 plus or minus 81 minus 48 is the same thing as 33 divided by 6. So that will be x equals 9 divided by 6 plus or minus square root of 33 divided by 6. So we're going to simplify. So we have 3 in 6, that's 2, 3 in 9, that is 3. So and you cannot divide anything. So the square root of 33 divided by 6 is the same thing as the square root of 33 divided by 6. We cannot simplify this portion of the fraction any further. So we're just going to leave it as the square root of 33 divided by 6. Assuming we could simplify further, we're going to simplify further. So our answer is going to be x equals 3 over 2 plus or minus the square root of 33 divided by 6, and basically this is the answer to the question. So what are the values of x that satisfy the equation? It is x equals 3 over 2 plus or minus the square root of 33 over 6, which is the option C, and this is the answer to our question. So the main tip in this question is for you to just observe the options as well as the complicated equation that we're given and deduce that we're supposed to only use the quadratic formula in order for you to save time on your exam and not ultimately missed the question by using the wrong quadratic equation method. I wish you guys all the very best. See you on number 2 of this series. Assalamu alaikum wa rahmatullahi wa barakatuh.